Hi everyone, today we're talking about how to interpret two-way tables. As a reminder, you do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. But be careful, make sure that you don't fast forward so much that you miss out on something important. Alright, so today's lesson is basically interpreting the meaning of two-way tables. So as a reminder, frequency, when we talk about just frequency, is a count of how many times an event has occurred. Relative frequency is going to be in a ratio or percent, showing how many times that event occurred out of a relative total. So you have to read the problem carefully. The relative frequency ratio is just the frequency divided by that relative total. Relative frequency percent is going to be the frequency divided by relative total multiplied by 100 to get it to a percent. If you don't have this in your notebook, make sure you have that and have it handy so that you can look at it while you're working on these problems. Okay, let's take a look at this example from Khan Academy for interpreting two-way tables. It says the two-way table of row relative frequencies. That's very important. Rows go left to right. So if you notice, they're giving you the row totals. So these numbers are the frequencies out of the row. So this is out of all English. This is out of all German. And this is out of all Italian. Okay, we don't have the column relative frequencies. We don't have the totals or the column relative frequencies for brown or hazel eyes, blue or green eyes, and other. Okay, so very important. So that's going to affect these statements later and whether they're true or not. So the two-way table of row relative frequencies below shows data on nationality and eye color. Based on the data, which of the following statements must be true? Pause the video and try it on your own first. All right, first statement. We're going to go down the row. It says there are the same number of English people and Italian people with other eye colors. Let's see, English people and Italian people. Same number with the other eye colors. It's the same percent out of the nationality. That is true. However, we cannot say that it's the same number of people. So this is 2%, right? If they both have 2%, that means something very different in both cases. Remember that this is the row total for the English. This is the row total for Italian. What that means is that there's 48% of the English people that they surveyed that have brown or hazel eyes. There's 50% of the English people that have blue or green eyes. And then the remaining 2% of English people that have other colors. So 48% plus 50% plus 2% gave you that 100% of the English people. Similarly, down here, 80% out of all Italian people surveyed have brown or hazel eyes. 18% out of all the Italian people surveyed have blue or green eyes. And then the remaining 2% have other color to make up the total 100% of Italian. What is a mystery to us is what this row total is for all of them. It doesn't mean that there were 100 people out of each of these nationalities. It doesn't mean 100 English were surveyed, 100 German was surveyed, 100 Italians were surveyed. We don't know what that row total is. So just because they have the same percent doesn't mean they have the same number of people, because it could have been that this 2% out of all the English people was 2 out of 100, right? Because 2 divided by 100 is equal to 0.2 or 2%, sorry, 0.02. But it could be that they didn't survey the same amount of Italian people as English people. This could have been, let's say, 20 out of 1,000 Italian people. They could have just surveyed 100 English people, and 2 of them had other colors to get that 2%. But they could have surveyed 1,000 English people, and 20 of them had other colors. So that 20 divided by 1,000 also gives you 0.02 or 2%. So the percents being the same does not tell you that they have the same number of people, because percents can be created by totally different frequencies and relative totals. So that's very important here, that they're only giving us row relative frequencies. For B, we have the claim that Italians are more likely to have brown or hazel eyes than Germans are. Italians, brown or hazel eyes, than Germans are. Italians are more likely to have brown or hazel eyes. They have a higher percentage, so it could be possible that they're more likely than Germans to have brown or hazel eyes. We're going to keep that in the running. For C, a German person is more likely to have brown or hazel eyes than to have blue or green eyes. Brown or hazel than blue or green eyes. No, doesn't look more likely. It's a lower percent, 47% compared to 52%. No. And then the last one, a person with brown or hazel eyes is least likely to be German. Brown or hazel eyes, least likely to be German. So they're saying if you have brown or hazel eyes, you're probably less likely to be German compared to English or Italian. You know what? That sounds very compelling because it's the least percent, but we just don't know. They haven't, we don't know if they surveyed the same amount of English people to German people to Italian people. Maybe they just didn't survey a lot of German people. Because of 47%, we don't know what that total is. We only know the row relative frequencies. Row relative frequencies doesn't tell us the total itself. So we can't make that statement. It sounds very compelling, but they could have just surveyed different amounts of English, German, and Italian. So it could have made those percentages look like they're the same or different. But again, with percentages, I could have 2%, because this is 2%. It could be 2% from 2 out of 100, which is only 2 people to get that 2%. Or it could have been 20 out of 1,000 people that I surveyed, which is still also 2%. 2 versus 20 is very different, right? So whenever you talk about the likelihood of somebody being a certain type of person based on we don't know how much total, that's a very tricky claim to make. But we can say that Italians are more likely to have brown or hazel eyes than Germans are, based on this data. Everything else is based on numbers as opposed to percents. All right, try this problem. It says the two-way frequency table below shows data on playing a musical instrument and playing sports for students in Jorge's class. Which of the following statements about Jorge's class is true? So pause the video and try it on your own first. All right, here they're not giving us any row or column frequencies. We have all the information here, so we will have to do some math because they didn't provide us with the percentages or ratios. We're going to go statement by statement. First statement. Students who do not play sports, so we're just looking at these guys here, are more likely to play a musical instrument than students who do play sports. More likely to play a musical instrument than students who do play sports. Okay, we do have to do some calculations. Students who do not play sports but play a musical instrument, that's 7 out of 10. When I divide that, I get 0.7. So we're really comparing 0.7. We're not comparing 7 to 6. Okay, we do have to read that problem. Students who don't play sports are more likely to play a musical instrument than students who do play sports. So here we do have to calculate 6 divided by 14 to get that answer. We're not just comparing 6 and 7 because their totals are different. So we can't just look at the frequency, we have to look at the relative frequencies. And this one right here is 0.42-ish. Okay, so let's see. Students who do not play sports are more likely to play a musical instrument, 70%, compared to greater than 42%. That seems okay so far. Okay, next one. The fewest students play both a sport and a musical instrument. Play both a sport and a musical instrument. The fewest students. That doesn't make any sense because the fewest would be 3. So that doesn't make sense. No, the fewest is 3. This one right here is talking about just the frequency because fewest means the number, the fewest number of students. So that we're just looking at 3. Okay, next one. Students who play musical instruments, these guys right here, all the people who play musical instruments, are more likely to play sports than to not play sports. Play sports versus not play sports. Okay. That doesn't make any sense because there's more people who don't play sports. So I could do the relative frequencies and all that, but I already know it's going to be less than. So that's no. Because, yeah, more people don't play sports. Okay, and then the last one, more students do not play sports than play sports. More students do not play sports. Oh wait, wrong one. Do not play sports is a total 10. More students do not play sports than play sports. Ooh. Yeah, that one is also good. Oh no, sorry. More students, no, that's false. More students do play sports. Okay, so that leaves us with A. Okay, and I wanted to check all of them just in case there was another one that did also kind of make sense, because when we do put in the relative frequencies, sometimes the way they write a statement would sound good, so it's an initial check, but later on when you read it again, you're like, oh wait, I didn't read it correctly. Okay, let's do one last one. This one says, a survey of a random sample of 9th grade students from Alabama asked whether the students owned a cell phone and whether they had brought a personal electronic device to use for school that day, for schoolwork. The two-way table of row relative frequencies below shows the data. So remember, we don't have the total, okay? So there's certain things that we won't be able to verify because we don't have the total. So we have to be very cautious about these relative frequencies. Go ahead and pause your video and try this one on your own. All right, I'm going to read through each statement. First one, 57% of students in the sample do not own a cell phone and did not bring a personal device. Do not own a cell phone and did not bring a personal device. 57% of the students in the sample, of all the students in the sample. Is this 57% out of all the students in the sample? No, it's out of this row, because this 57% plus this 43% makes that 100%. This row's 20% plus 80% makes that 100%. So this 57% is the students who don't own a cell phone. This is out of all the students who don't own a cell phone. So we're comparing all the students who don't own a cell phone who didn't bring in their device. Not all the students, period. This is only the students who don't own a cell phone. Okay, so this would be not correct because it's not out of all the students. This is out of all kids with no cell phone, period. Not all the kids total. All right, next one. A student who owns a cell phone, is less likely to bring a personal device than a student who does not own a cell phone is. Maybe, yeah, because this is 20% compared to 57%. Less likely. A student who owns a cell phone is less likely to bring a personal device. Oh, sorry, wrong one. These guys, less likely. Oh no, that's not correct. Okay, student who owns a cell phone is not less likely to bring it. They're more likely to bring it, right? So no. 80% is actually greater than 43%. That's why I had to read that one correctly. Okay, third one. A student who owns a cell phone, is more likely to have brought a personal device than to not have brought one. Yeah, more likely to bring one. Yes. Could work. And a student who did not bring a personal device, so these guys, is more likely to not have a cell phone than to have one. More likely to not have a cell phone than to have one. Oh, that could be possible as well. So it could be C or D. Okay? So one of them is a trick because both of them sound right. Let's see which one is the trick. Okay? Is it that a student who owns a cell phone is more likely to bring in a cell phone than to not bring in one? That's 80 versus 43. Or sorry, 80 versus 20%. Okay. Or is it that a student who did not bring a personal device is more likely to not have a cell phone than to have one? The answer at the end, is C. Because D cannot be verified. Okay, and I'll show you why. A student who did not bring a personal device, so we're comparing these two guys. We cannot compare two different row relative frequencies. This 57% we don't know is out of what total, and this 20% we don't know is out of what total of theirs. So if they're from different rows, we cannot compare those 2%, because this 57% could be out of 100, while this 20% could be out of 1,000 or something. So it's a different amount that we're comparing them to. Okay, while C is just comparing people who own a cell phone. They're comparing the 80% to the 20% out of their own total. So that percent is comparable because they're out of the same total. So we can actually compare those. If you're comparing two different rows from row relative frequencies, it's just too much is a mystery in terms of their total. Okay, so be very aware. Go through every single statement, and then at the end, if you have two that are very convincing, re-examine them again and see if you can actually trust that comparison. Because with row relative or column relative frequencies, there's a lot that we don't know about. So it can look deceivingly true. Okay, let me know if you have any questions as you work on these problems, and I'll see you in class.